Okay, hello everyone. So yeah, as people have said before, I'll be going over these problems. So the first one is we have this horizontal thin rod of mass M and length L. And so it rests at one end on a support like this. And it's suspended by a string on the other end like this. And so at some point the string is burned and we want to find the force F exerted by the rod on the support immediately afterwards. So now this is a very classic mechanics problem. We just want to write out the equations and it should be pretty clear how to solve it once we write them out. So if this force is F going upwards, and then there is this force gravity, which is obviously mg. So now we want to write our equations for this system. The first one is the equation for the total force. If we take the downward direction to be positive, then it's mg minus n is equal to ma, where a is the acceleration of the rod at this instant. So that should be pretty obvious. And then we also want to do something with torque. Since obviously we can't solve this equation at first, we need another one. So if we take it to be the torque around the center, then we don't have to consider the force mg because that would give it zero torque. So then torque is this force F. My bad. One before should be F. The force times the distance to the point, which is L over 2, has to be equal to I alpha, where I is the moment of inertia and alpha is the angular acceleration. And so we also know that A is equal to alpha times L over 2. This is just how angular acceleration is related to the acceleration. And because we're measuring the torque around the center of mass, it's L over 2 instead of like L or something else. Okay, so now we need to know the value of I, and here I is equal to 1/12 ml squared. This is because we're measuring the torque around the center of this rod. And so then we need the moment of inertia of a rod while we're measuring around the center, and this is 1/12 ml squared. It's different for other like shapes and points you measure from, and you should probably remember this value for I. For both this particular case and for a bunch of the other common ones, for example, the moment of inertia around the end or like a ball or something. So anyway, now it should be pretty easy to solve it. We have that F times L over 2 is equal to 1/12 ml squared times alpha, which is equal to 2a over L. So then we can see that these L's all cancel out. And then we get that, so we get F over 2 is equal to 1/6 ma, I believe. Yeah, so then we get that 3F is equal to ma. So now we can return to the first equation. 3F is equal to ma, so then mg minus F is equal to 3F, which means that mg is equal to 4F, so then F is obviously just equal to mg over 4. So that's the answer to number 1. Does anyone have any questions about this problem? Okay, then I'll assume no one has any questions. So I'll move on to the second problem. We have this conducting bar of mass M here, and it slides down down two vertical conducting rails. Yeah, and these are conducting rails, and it's separated by a distance L. And yeah, and they're joined at the top through an unknown resistance R here, and there's a magnetic field pointing into the page with magnitude B. And so, yeah, and we know that the bar falls with a constant term of speed V0, and we want to determine the voltage induced in the bar. And I know this problem says only to find the voltage, but I think it's also pretty interesting to find the current and the resistance, because they all fit together well with Ohm's law. So like, yeah, I'll do that. Anyway, to find to find the voltage, we know that the force F is equal to QV cross B. Like, this is a pretty standard equation that is like one of the most first things taught in like electromagnetism. And so we also know that F is equal to QV, well, not QVB, my bad. It's equal to QE, where where E is like the electric field. This is also something really standard that you should probably know. So then, obviously, we can relate these two expressions. We get that QE is equal to QVB, which means that E is just equal to VB. And so there's this other equation that says that this epsilon, the voltage difference, is equal to E times L, where L is the distance. This is for like when we're trying to find the voltage difference between 2 points that are a distance L apart. So we can see where this comes from. And this is just equal to VBL, obviously. So that's the answer for the voltage. And now if we want to find like the current and the resistance, well, to find the current I, we know that mg is equal to IBL. This is because IBL is a force generated by the current going upwards. Yeah, you can verify that this goes upwards using like the right hand rule, I believe. So then these two forces have to cancel out, and yeah, they have to cancel out in order to create like terminal velocity v0 without any acceleration. So then, yeah. Also, you should probably remember that this force is equal to IBL, and you can try derive it on your own. This gives us that I is equal to mg over BL. And also, of course, the last part of Ohm's law is, well, R in V equals IR. We know that epsilon has to be equal to IR because it's it's just like a circuit. So then R is equal to VBL over mg over BL, which is equal to VB squared L squared over mg. So that's the answer for R. And so they all fit nicely if you look at it from like an Ohm's law perspective. So yeah, that's the answer to problem 2. Does anyone have any questions? Okay, if not, then that's it for me.